solve the equation, indicate any extraneous solutions by crossing them out. We have here a radical equation, and so that we know to solve this, we'd like to get rid of those radicals. To get rid of a radical, we'd like to square both sides of the equation. And unfortunately, squaring sometimes introduces these extraneous solutions. So that's why we need to make sure that at the end of this problem, we check our answers and see whether or not they're actual solutions to this problem or if they were extraneous solutions and don't really work in our case. So let's go ahead and square both sides of this equation. Right? We'll square the left and we'll square the right. And on the right, I have a square root of something squared, so I just get the innards, just get that radicand, 2y plus 1. On the left, I have a product. Squaring a product is nice. I just got to square the pieces, so 2 times 2, or 2 squared is 4. Square of square root of y minus 3 is y minus 3. And of course, I'm multiplying this 2 squared by the whole of this square root of y minus 3 squared. So I'm not just doing 4 times y, I'm doing 4 times y minus 3. So don't forget those parentheses, because now we have 4 times y minus 4 times 3. So this is a 4y minus 12 that we're working with. So we have an equation here, 4y minus 12 equals 2y plus 1. We can go ahead and try and solve. Let's subtract 2y from both sides. 2y from 4y is 2y. Let's go ahead and add 12 to both sides. 1 plus 12 is 13. Divide by 2, we get y equals 13 halves. So there's our proposed solution. We want to go ahead and check whether or not it's actually a solution to our problem. So we need to plug it into the original equation. We can't plug it into the squared version of the equation. So let me erase the squaring that I did on that thing. I'm going to plug it into our original equation. So let me do this in a different color. So if I take and plug in 13 halves, I'll take 2 times square root of 13 halves minus 3, and let's see what we get. I can't do the subtraction until I get a common denominator, so I'll multiply by 2 over 2. Now I have these both fractions over 2. I have 13 minus 6. 13 minus 6, of course, is 7. So we have 2 on the outside here, 2 times square root of 7 halves. All right, let's see what we get on the right. On the right, we have a square root of 2 times y. Y is 13 halves plus 1. The 2's cancel. I'm left with 13 plus 1. That's 14. So I have the square root of 14. And so I say, oh, those aren't the same. Or are they? We need to do a little bit of work to check this. Just because they don't look the same, they might have the same value. We need to play around with them a little bit to see whether or not we can morph one of these into the other. I think it's easiest to maybe play with this first one that we did. Let's put the 2 inside the square root. So to do that, I'd like to replace the 2 on the outside with something squared on the inside, right? So what I need to do is replace that 2 outside with a 2 squared on the inside of the square root, because now I know this 2 squared could factor out of the square root and turn into a 2, what we have there. So if I want to put something inside a square root, I square it, put it in. Well, and what do we have now? 2 squared divided by a 2, one of those 2's cancel, and we're left with just a 7 times 2 on the inside. So that's a square root of 14. So these two answers are the same. So this solution does work, right? So this gives us some reason to pause when we're checking whether or not a solution is extraneous or not, because we sometimes are going to have to do a little bit of work to get one of them to look like the other one. But we can do it, and there's our answer. Y equals 13 halves.